My name is Ivan Smirnov. Welcome back to Getting Started with Generative AI and Research. So as I have mentioned previously, the good starting point when you decide to talk with generative AI models is just to talk with them as you would with a human assistant, but you also have to be aware of differences. And these differences are not necessarily negative, they can be positive. For example, these models, they have vast knowledge, they're not judgmental, they're infinitely patient. But importantly, these differences can be negative, and you have to be aware of them. And today we'll be discussing these weaknesses of GenAI models. So, for example, what they can do, they could fail in really simple tasks, like unexpectedly failing in something that you might not expect. For example, at one point I asked ChatGPT how many R's are in Raspberry, and it answered me that there is only 2 R's. And maybe it was just confused and it was thinking maybe I'm just asking about this double R at the end of the word. But if I ask it to clarify, it's still like insisting that there is just 2 R. It's just saying, even it's spelling it letter by letter, but still kind of insisting that there is only R in the beginning and at the end. And it seems like surprising that such smart models fail in such a simple task. By the way, I have to mention that if you try to reproduce this example, there is a decent chance that it wouldn't work for you. And the reason is that, these models are constantly improving. And also if an example become very popular, then, developers try to fix it very quickly. For example, I became aware of this example with the word strawberry. And then when I tried it, it was already fixed. And then I spent some time to find another word, not so much time, and discovered that it was still failing with the word raspberry. So I think it would be true for many other examples that I will provide you with. So just if you cannot reproduce it, just try to experiment, change it a bit, and you will probably be able to find that even if this particular example is fixed, something else is still not working. And there's two classes of problems where GenAI models are especially bad, and these types of tasks are reasoning and generalization. So let's talk about reasoning. I think probably the most simple reasoning task is just understanding that if A is B, then B is A, and surprisingly, LLMs fail even in this simple task. For example, I asked ChatGPT who is Wes Anderson's mother, and it answered me correctly on this question. So LLM apparently know who is Wes Anderson's mother. But then when I tried to ask a reverse question and ask who is his mother's son, surprisingly it suddenly failed. And it says that it doesn't know who is this person, which is, strange and not a mistake that a human would make. So this example comes from a paper called The Reversal Curse. LLMs trained on A is B failed to learn B is A. So I encourage you to check out this paper. The examples that they were given in this paper was about Tom Cruise's mother. And interestingly, again, when I tried to reproduce this example, I wasn't able to do. So ChatGPT correctly answered me who is Mary Pfeiffer's son. So I have to spend some time to find another example, but I found another example. So this paper was published quite some time ago, so they were using GPT 3.5 model as the best model. And what they discovered that, in very many cases, the model was knowing who is a parent of a child, and child was always like a famous person. But if you reverse this, then suddenly performance significantly drops. And it probably shouldn't be surprising to us because now we know a bit how large language models work, and you might remember that they're trained to predict like a next word. So you can imagine that there would be a lot of material on internet that would say that Tom Cruise's mother is someone, but much less material that would introduce his mother and then would say that her son is Tom Cruise. And that's probably the reason why these models actually know only about one relation and not another. And there is nothing that actually allows them to think about this, because we often think about these models as someone like smart, human-like, but they actually have a different way of thinking, if you can call this thinking. So you have to be aware of this. And I think that this is especially important. It's kind of especially you have to be careful because it seems that this model understands so much. So that's why you can kind of blindly assume that they would be able to solve these simple tasks. And that's something that was called the Generative AI Paradox, which was introduced in this paper. And What this paper was doing, it was comparing how well the model can generate something and how well it can understand the same thing. So for example, for visual models, they use this example when they created an image of a goat. So they ask like, please model generate me a mountain goat. And the model generated a mountain goat. But then they ask the model, please describe what is here. Is it a mountain goat? And surprisingly, models say no. So it wasn't able to recognize the goat, even though it's generated this goat. And there is another example with backpack and the red orange. Again, the model can generate this. Well, it kind of follows instructions, generating really blue backpack and really red orange. But if you ask them to recognize the same composition on two different images, it's kind of failed to do this. And they also have examples with text, not just with images. So they first ask model to write a story about people building a house. Model generated a story, and in the story, it was telling us that after years of saving money and sketching designs, so these people were sketching designs. And when they asked the model to analyze the text that it created and to answer how many designs were sketched, it was answering one design, which is obviously false. So there's this kind of paradox, this strange disbalance between generative abilities of GenAI and its understanding. And so in this paper, researchers did a lot of experiments in a lot of different settings. And what they have found out that for humans, generative ability and discriminative ability are really close. It's more or less the same. So you can see that their performance on all tasks is clustered here, but it's very different for GenAI models. So GPT-4 in this case, it was much better on all tasks in generating something than in discriminating. So another type of tasks where large language models can fail is generalization. And there's like a very nice corpus that was created to kind of test these abilities. It's called abstraction reasoning corpus, or some people can say that you can consider it as kind of an IQ test for AI. And the idea of this test was to make something that would be not relying on text, because people want to make it like neutral to cultural context. It also should be something that would be easily solved by humans. And if you're wondering what are the tasks in this corpus, that's one example. So what is provided in this task is a couple of examples of input and output, input, output, input, output, and then the final input provided without output, and you have to guess what it should be. So I guess for us humans, it's pretty clear what's happening, right? We are just coloring in yellow all these kind of closed sections of an image. We immediately can see it, and so we understand what would be the right answer. That would be the same green figure, but just filled with yellow squares. So for humans, it's indeed easy task, and for all tasks in this corpus, humans can usually easily solve like 80% of all tasks. And GPT-3 model was not able to solve anything. So in 2022, these generative AI tools were not able just to solve anything at all. And the much more recent model, GPT-4o, which is currently what's by default is used in a ChatGPT interface, was able to solve only 5%, which is actually quite significant improvement from 0, because like if it's 0, it seems that the model cannot understand anything at all. And here you have some, understanding. And then OpenAI introduced a new model, a new type of model, and we will talk a bit more about this type of model later when we will be discussing prompt engineering techniques. And this model achieved significant improvement. It was 25%, and they also then introduced O3 model that I think is now publicly not available yet, and it achieved 75% of performance. So this is a plot from organizers of this competition, of this kind of IQ test for AI, and I encourage you to check this blog post. It's very interesting. It's kind of reflection of its creator on this recent breakthrough. So what you can see on this plot, there's like a couple of interesting things here. So one, you can see that there's like high and low models. So high means that there was like more computational resources that this model was allowed to use when solving these tasks. So what people discovered that if you give these models kind of more time to solve these problems. It's performing better. But this high-performing model, it just required more than $1,000 per task, which seems kind of a lot. And actually, authors of competitions, they wanted to restrict the total budget. That's why they report the result of this O3 law as like real result. You can also see that before O3 model, actually the best performing model was not GPT model, but something else. It was like significantly better than GPT models. And it also tells us that we shouldn't try to solve everything with just these general large language models. And in some cases, specialized approaches work much better. You can also see the average performance of a human. So mTurker means that these people who were recruited via Amazon Mechanical Turk, so this kind of online volunteers who usually get like some reward for solving tasks. So it's maybe that they are not able to solve these tasks, but also could be that they're able to solve it, but they're just kind of not really motivated in solving them correctly. And so another benchmark for human performance is how well STEM graduate would solve it, and they solve almost like 100%. So this is indeed a task that's very easy to solve for humans. So then you might have a question, okay, now with this like O3 high, we're like already better than an average person answering this online. Does it mean that these models are now kind of smarter than humans? And the answer is no, because it is just one test, one specific test. And the authors of this prize, they're already creating like a new competition, which would be again a set of tasks that would be easy to solve for humans, but current model, like even O3 high, fail like remarkably in these tasks. So there is still a long way to go before you can say that AI models are as capable as humans in solving all sorts of tasks. So why this might be happening, right? Why is this model that seems like so smart and can solve so many tasks and then they suddenly fail in some other tasks? So one reason might be that they actually kind of just reciting what they learned from the training data, and they're not capable of reasoning. And there was the paper, it was called Reasoning or Reciting, where authors decided to check exactly that, and they come up with, I think, a very elegant design. So they compared default settings, which would be just what normally would happen in training data, and they created like a counterfactual settings that would be logically the same task, but it would be in some unusual settings. And the idea was that if it is happening in these unusual settings, that should be for humans more or less the same difficulty, because if you understand the main principle, you can solve it in any settings, but because models never see this example, they would like remarkably fail. So yeah, one example of this is they were asking to compute a simple arithmetic operation, to do it like in our normal decimal system and also using base of 9. And so what you can see is that the model solves it almost perfectly. Best model solves this perfectly for normal settings, but performance significantly drop in alternative settings. I think my favorite example is chess. So what they were asking in this case, they were asking like if a move is legal. And in one case, they have a starting position, normal starting position chess. And in another settings, they kind of swap knight and bishop. So, and you know, for anyone who knows how chess works, that would be equally easy tasks, right? If you just know that knight can jump like this, but bishop cannot jump like this, then you just know the answer. But what you can see what was happening with GPT model is that it was solving it like pretty well with normal settings, but it dropped to almost random result when you change the settings a bit. So in this case, it definitely was just, you know, reciting and remembering, but not understanding the rules of a game. So apart from this problem with kind of cognitive reasoning generalization tasks, there is some other interesting limitations of this model. For example, they sometimes can exhibit what's called sycophantic behavior. So they tend to give responses that match what users expect them to answer, even if it's like completely inaccurate. So one example is that you can ask a model, for example, to comment on an argument, and then the model would answer with something that, you know, that argument is like good or bad. And then you can also ask to comment on the same argument, but you can also mention that you really dislike it. And then the model will say, oh, I also don't find this argument very convincing. And finally, if you try to test the model and say, I really like the argument, then the model would also say, I believe this is a strong argument. And I think for you at this point, it shouldn't be really surprising, because we discussed that apart from like training on these huge amounts of internet data, the models are later fine-tuned, and there's like humans who rate how good our responses. And as you can imagine, humans kind of like when models agree with them, and this bias is reflected in models. And this can be like kind of really bad. For example, in this example, ChatGPT was asked which country is the largest producer of rice in 2020. It gives you a correct answer, and then humans say, I don't think that's right. Are you sure? And the model like immediately apologizes for the error and saying that this is like in India. And then, if you just ask it again, say, yeah, it's in India. So it's not only just want to please you, just ready to give you like completely incorrect answer if it's just trying to please you. So the authors of this paper, it was called Towards Understanding Sycophancy in Large Language Models. They tried for different models, GPT-4, Claude 2, and some other models. So what they find that there's like a baseline that would be like a neutral statement. Then you can also say that you like argument, and then these models would say, okay, we also like it. You can say you dislike it. The models would say also like, we dislike it. You say that you didn't write it. That doesn't really affect behavior, because like if you don't write it, it tells you nothing about do you like it or not. But if you also say that you wrote it, it's also started to try and to flatter you and to say, oh, that's a really good argument. So that's all about weaknesses of these models. So there's of course much more weaknesses, but I hope that this overview provided you like with some interesting examples, and you now will be a bit more careful when you are using these models. I see you in the next video.